Hello, hello again, I should say. Welcome to this uh, hopefully short and sweet tutorial, simple and exact, targeting how to get large landscapes in Unreal Engine 5.3. Now, this is not a method for increasing your height map resolution or anything like that. This is for using or utilizing the maximum uh, texture resolution for terrains, which is 16321, and basically scaling them up to your desired kilometer squared range. This is basically the method we're having to use at the moment. So it is a kind of pull and stretch method, but it works perfectly fine. There is no issues with it. Right here, I have an example map from one of my personal projects, um, from the Zarthia universe that I'm about to begin serious work on. But that isn't the point of the video. This is just what this terrain is. This is what this world is. So it's kind of a little sneak peek to that landscape. But yeah, essentially, this is a smaller version of the landscape utilizing the same height map. This is a 20km by 20km example, which I will run the level on quickly. Let's find a nice juicy spot, something like right here, and I'll play it just to show you it running at 120 frames. I am also running Ultra Dynamic Sky just as a quick preset for lighting. And there you go, you can see the map working pretty well. And you know, some people probably think that, oh, the resolution's not that great, but you know, like, really, it doesn't matter. It doesn't matter, because once you start utilizing all of the new features that are going to be coming later on, as well as, you know, texturing and covering it with rocks and stuff, this resolution really is just kind of like a foundation and distance kind of view for you to play with. So blowing up landscapes or scaling up landscapes kind of isn't a major problem. So, without further ado, as they say, let's get on with it. What I'm going to do is start from scratch. So it's asking me to save it, but I'm not going to. We're going to create a new level, an empty open world level, and create. I am not going to save. So, the saving thing, obviously you don't need to worry about. That's just a bit from my my version of the project. So, first things first, what we're going to do is jump into landscape mode. One thing I would say is if you, I had this world partition window open. Sometimes I get a bit of a frame rate drop. You can see it doing some kind of flicker sometimes. Okay, it's not doing it now, but sometimes you get a little bit of a FPS flicker from this window, and it bugs out a lot. It really annoys me that this can be really good at the start, but then it just stops working. Plain and simple. It should give you a random value. Really annoying. I hope they fix it because it really does annoy me. Anyway, I'm going to go to the details panel so that we don't have um, any extra potential lag. And we're going to jump into landscape mode. And as shown in one of my previous videos, oh, we have a major lag going on. What's happening there? That wasn't very good, was it? Okay, yeah, so I'm going to reset all of this because that was actually settings from uh, the previous one I added in, so we can start from scratch. So in my previous videos I kind of went through the process of importing landscapes correctly without getting the horrible bugs that 5.3 has with landscapes related to import from file. For some reason I've just not managed to successfully import from file directly without having like landscape tiles, proxies floating up in the air, or some of them being flat, not recognizing the height map data or something. So the way around it I found is to create the landscape first and then import the height map, and that seems to avoid all of the issues from the what am I trying to say from the bug. It just avoids the bug basically. So what we're going to do is, utilizing that same method, we're going to set up our landscape for a 16,321 by 16,321 resolution landscape, which means we'll have to go 255 by 255, section size, sections per component being 2 by 2. The components would be 32 by 32. Now that gives us our correct resolution and our correct components for this resolution. We want to keep this number down as low as possible, but to a power of 2, you know, the typical resolution scales. So we got to this stage, that's all good. Now what we want to do is to calculate our scale relative to our desired kilometers squared. Now, if we were to just hit create now, we would get a 16.32 kilometer by 16.32 kilometer landscape, which is essentially this resolution. We don't want that. In this example, I'm going to show a well, in the previous one I did a 20 kilometer landscape. Let's do a 30 kilometer landscape. Okay, we'll do a 30 kilometer landscape just for fun. So what I'm going to do is I'm going to create a little sticky note and write down the calculations. I'm also going to have my calculator here for you to see. So scale, oh, where am I typing? I was typing, but I had no idea where. Okay, scale up method. So I'm going to bold that, and I'm going to first determine the red and the green, which is the X and the Y axis. So X, Y axis, and yeah. So the calculation for that, really simple. It is the desired kilometers times 100 divided by the height map resolution. Okay, so I'm just going to put that in brackets as our little note for that. Excuse me. And basically we're going to do that calculation. So our desired landscape kilometers size is 30 kilometers, but you wouldn't put 30. We have to put the value of 30,000 because it's in the smaller range. So we want to go 30,000 times 100 divided by height map resolution, which in this instance is 16,321. Now that is our calculation that we need to do in the calculator to get our X and our Y scale value. So jump into the calculator. We're going to do 30,000 multiplied by 100, which gives us 3 million, divided by 16,321. And this gives us 183.81 blah 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 blah. copy that value and then put that into one of these fields, and it will automatically do the other one for you. And well, that is it. It's as simple as that for our x and our y calculation. So now we need to do our z-axis, which is just as simple, pretty easy in fact. So what we need, I'm going to first do our note, which is our height, desired height, times 100 divided by 512. Now there is another version, another way of doing it, which is height multiplied by 100 multiplied by some very different number, which I'm going to copy, and then I'll show you the documentation, which is multiplied by this number. Essentially these are exactly the same calculations. For me, I prefer just sticking with this one because I think it's easier to remember than this disgusting number here. So what I'm going to do is actually pull over the Unreal documentation, which is our landscape technical guide for 5.3. Above it has the calculations for the other dimensions, but right here we have the calculating heightmap Z scale. So I'll just run through it. I'll read it, not essentially explaining it, but Unreal calculates your heightmap height by using values between -256 and 255.992. So I'm just turning my music down slightly. Hopefully it isn't too annoying. Stored with 16-bit precision. The calculated height is then multiplied by the z-scale value that you input when you import the heightmap data. For example, a z-scale value of 1 results in a maximum height roughly 256 centimeters and a maximum depth of -256 centimeters. Therefore, I almost said it with a th then. Therefore, a default z-scale value of 100, at a default z-scale value of 100, your height values will be between 256 meters and -256 meters. Oh, yawn. Horrible stuff. Makes me feel sick. But anyway, calculating the custom height requires a use of a ratio to convert your custom height value into -256 to 256 range that Unreal uses. Since the height range is a total of 512 units, -256 to 0 is 256 units, and 0 to 256 is another 250 ratio, blah 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 blah. You can see it. 512, alright? It's simple. It's 1 divided by 512, or this horrible number. So essentially, it then explains here that you multiply your desired your desired height by 100 to convert height into centimeters, and then next multiply this new value by the ratio. So that is basically this height, desired height, multiplied by 100 to get your centimeter value, then you multiply it by this. So, that was tiring, but you can read that documentation if I just kind of rushed it, which I did rush it, or hopefully you understand what I'm saying. So I'm just going to show you both of them, proof that they are the same calculation, and then you can decide whatever one you want to use. So for this height map example, I'm going to make it 5 kilometers high. So we're going to use 5,000 as our desired height multiplied by 100 equals 500,000. Then I'm going to multiply it, excuse me, my throat's a bit dry, and then we're going to multiply it by this number, and we get a value of 976.5625. And I'm just going to note that down here. So that is essentially a calculation of 5,000 times 100 times this sickening number equals that. Okay. So yeah, that's that calculation. Then the first one, which I think is much easier to remember, is your desired height, which is 5,000 times 100 equals same thing, divided by 512. And would you know it, we get exactly the same. So 5,000 times 100 times divided by 512 equals, copy it from here just so it's the exact one. There we go. And that is it. It's as simple as that. So now I'm going to close our calculator. I'm going to grab this value and I'm going to whack it in the Z. And now this should be a 5 km high map, 30 kilometers squared on the X and the Y. I hope it doesn't crash because I've been talking, building up to this point for a while. And then we hit create. I'm going to do 30 by 30 test, or showcase I should say, and that all looks good to me. Save, and then it starts importing. This might take a little bit because it is quite large. Okay, so as you can see, I'm back in the landscape mode, and I am on like take 5 or 6, I think, of this section, because I was getting errors, not errors, I was getting problems with the regions. They were like doing crazy stuff, and then I was looking around thinking why, and then I remembered reading a while back about the decimal places of the scales causing errors for the regions. So I tested it out by removing all of the decimal places, and I had a perfectly fine import. Then I recorded it, and then it didn't work. So I'm now trying 184. I've rounded up basically our values. I have rounded up the value to a single 184 for the X and the Y, and then I've removed the decimal places for the height. And I'm just going to see if that works. Ideally it does. So I'm going to you can see that I've done it a couple of times. I'm going to create a completely new map because it seems when I overwrite this causes problems as well. So I'm just going to do showcase 2 and we'll see what we get. Actually, on one of my takes, I did 976.5 in the X and the Y by accident, and I got a 156 km map with a perfect setup. And I thought, well, something's not right, because the regions were even, they worked fine on a 156 km landscape. but all the values are square, so I don't know. Square to each other. So we had the x, y, and z all at 976, and yeah, super confusing. So it's something to do. I mean, what that showed me is that it's something. There's an issue with the regions relative to the scale, and it doesn't know really how to. I mean, either that I don't understand it correctly, or that there's a problem with it. It can't adapt. You know, they don't scale properly with the environment scale. So yeah, hopefully this is the one. Rounding it up to a whole number. Well, hey, success. So this is exactly what I wanted to see. We have our 4 regions covering all of the proxies, which we can see here. We can see all our proxies behind these 4 big squares, these smaller ones in here. And we have our 4 regions aligned properly. And then when you look here, we have a 30, in this case 30.3 because I've rounded up. So a 30.3 kilometer squared terrain. So I'm actually going to save it at this point, which I don't need to do actually. I'm going to load first. Load these regions so we can see them in all their glory, which would just be flat proxies. And that will take some time depending on your machine and your RAM and VRAM and whatever. Oh, I didn't like that. That looked a bit glitchy, didn't it? Okay, so there we have it. We have our 4 regions controlling our proxies, which is exactly 256 selected. Delicious. So, what I'm going to do now is add in our height map. From the previous video, we could see that we have to add it in via this Manage tab. We then go to Import and we select our height map file. We then open this up. This is on my other window because I have stuff that I can't show publicly from commercial projects. So I'm going to choose my 16 file called iOS 16321. That should show up any second now. There we go. And it shows you our import resolution, which matches the resolution of the terrain perfectly. And in this mode option, you can choose all if you haven't got the terrains loaded, the tiles loaded. But I like to load them before and have loaded only selected. That seems to give a more solid result from my experience. Obviously not everyone can do that with their machines, but this is how I have managed to avoid bugs in the past. But as my last few takes have shown me, we can get bugs even when I'm trying to teach you a specific way around bugs. So I'm hoping that this goes alright. The terrain might look a bit strange, might be a bit too high actually for the size, but because I did a 5 kilometer total height, which when I think about it might be too big. But we should see the grid pop down. There we go. Yep. Not the grid. The terrain pop down from the grid, and that shows us that we have applied our height map. And then if we go to the side, we should see some height data. Yep, there we go. Now we can leave landscape mode. I would always give it a good save at this stage. which I'm using Control Shift S to do save every file that needs to be saved in the project. And we are one step closer. And now we're in lit mode, but we have no lighting, so we're happy with that. That is essentially the tutorial done. But I'm going to show you it with lighting and run around and then show you one last thing. So yeah, this map looks ridiculous. I've got the height wrong, but it doesn't matter. For the sake of this video, this is going to be perfectly fine, because this map is not supposed to be this high. I think it's probably around 3 kilometers high for this scale. But it all looks fine to me. Get our clouds about the right height. I don't particularly want them to be that high. That low, sorry. I want the fog to be lower, but okay, we'll just go with that. So, we have our 30km squared map. Then we press Alt P. Oh no, I better not do that. I'll just play from let's play from this side here. And would you look at that? We're up in the clouds. And you can see that there are parts not loaded. I'm just going to run a command r.streaming.pool_size 0 just to get rid of that streaming pool error. Well, not error, warning. And you can see basically that we can't see the entire map. So we need to fix that. And how, yeah, so that's basically meant to be our view. You can kind of see that we're supposed to have seen that. Way of dealing with that is, I just like to minimize that for the sake of it. We need to go into our world settings, which I believe we can get up in window and then hit this world settings option here. This will bring this tab open. And then we need to go to our world partition setup tab, runtime settings, grids, index, and then we want to look for this loading range value. I would say snap the preview grids on, and that shows you our tile loading range, essentially our proxy tile loading range. And we want to expand this. I'll just add a 0 on, and you can see that now we're going to start loading these tiles. I'm just going to put it to an absurd scale, like really absurd, so that the whole landscape is rendered on runtime. So yep, we're happy with that. I'm going to save it again just because I like to do that wherever I can, and I'm going to play from here. And now we can see our entire landscape is running. Not the prettiest of landscapes because it's stretched way too high. It's not meant to be this tall. But you know, it is what it is. So I'm just gonna play around with the cloud height because I think that's what makes it look so disgusting. And then if we get the, where's the height fog? I'm using ultra dynamic sky just as kind of what am I trying to say? A example preset. Oh no, it's not that, is it? Fog intensity? No. I want the height, so height fog. There we go. Let's bring that down from the clouds a little bit. Let's find a more interesting region. Okay, let's bring that right down. That's the problem with having such a big height. You kind of end up with this really, really difficult to work with. Oh, it's okay. That's in the blueprint. You'd have to change that. Okay, I'm just gonna lower it then, and then jump to here. Don't worry, those shadow issues are just exactly that. That's just you know, once you go over them, they disappear. Something that again I hope they fix. But there we go. F11 stat unit stat FPS shows that we're running full landscape loaded 120 frames a second with UDS. UDS not looking so great because I've got the clouds up probably way too high, looking a bit strange. But we got what we wanted. And yeah, hopefully that clears things up. So just as a little final bit, thought I'd show. Now I've just done some light adjustments in UDS, some color adjustments and stuff, just to show you what you can get. Just as a little final bit, you know, why we like Unreal, as annoying as it can be, how quick it is. You know, this took me 2 minutes to do, and you know, now we've got a pretty cool, you know, slightly stylized thing. This is with UDS, Ultra Dynamic Sky. You know, just softening the clouds, making them bigger. You know, you can get some pretty cool effects. I think it's pretty fun, and yeah, you know, 30 kilometers squared, running pretty good. No materials yet, so we'll have to see about that. But yeah, I mean, if you like these videos, please, you know, keep having a look. I will be putting some links to my Discord channels related to the game I'm working on, stuff like that. So jump in there. There'll also be, you know, in my uh, what do you call it, like connected channels at the bottom of this YouTube channel will be the Tecastus um, YouTube channel, which will also be where I post devlogs very soon. There's a couple of old ones, but I wouldn't use those as too much of a reference. But this is essentially, you know, um, going to be one of the platforms as well as that one where I post stuff. So yeah, anyway, hopefully you have got what you needed from this video and learnt something. I have myself learnt something. The issue with the decimal places when we're scaling up, that's definitely something that needs to be fixed by Epic, and hopefully they do take it and fix it. But yeah, I think it's pretty cool. It's pretty exciting. I'm excited for Unreal 5.4 and look forward to doing more videos as I discover new things. So yeah, hope you enjoyed it. See you next time.